Myself, Milan Patel, Assistant Professor at LJIET Institute of Engineering and Technology. Today's topic is about linear measurement. In today's lecture, we will cover introduction of chain survey and various operations involved in chain survey. Let's start with introduction of chain survey. So what is chain survey? It is the survey of measuring distances on the ground. The main principle of chain survey is triangulation. It is used to divide the area into number of triangles of suitable size, which is called as triangulation. If the area to be surveyed is triangular in shape and if the length and sequence of its three sides are recorded, the plan of the area can be easily drawn by chain. This is called as the principle of chain survey. Second topic is number of terms related to chain survey. Let's discuss number of terms involved in chain survey by this figure. Suppose there is a plot having boundary stations are A, B and C and D. First term is survey stations. These are the stations which are at the beginning and at the end of the chain line. So here A, B, C and D as well as S1, S2, T1 and T2 are the number of survey stations. Second is main stations, which are along the boundaries. Here A, B, C and D are called as main stations, which is denoted by capital letter A, B, C and D. The line connecting main survey stations are called as main survey line. Here AB, BC, CD, DA, BD are the main survey lines. The longest line is called as base line. Here BD is the base line. Next is subsidiary stations. The stations which are on the main survey lines are called as subsidiary stations. Here S1 and S2 are the subsidiary stations. The subsidiary stations are denoted by capital letter S. The line connecting main survey station and subsidiary station is called as check line. It is usually used for checking the accuracy of the work. And the last is tie stations and tie line. It is usually used when there are chances of long offsets. So what is offset? We will cover in the next topic. Offset is the distance between the object and the chain line. Long offset should be avoided in chain survey. For that, tie line or tie stations are used. The connecting points of tie lines are called as tie stations. It is denoted by T1, T2, T3, etc. That's all about various terms related to chain survey. Now let's discuss selection processes for survey stations or various points involved in selection of survey stations. First is the station should be intervisible, means second, the survey lines should be minimum as far as possible. Third, station should form well conditioned triangles having angles about 30 to 120 degrees. Fourth, station should be so located that all types of lines are formed in the drawing, like main survey line, check line, tie line, base line, etc. Next, station should be selected within the boundary of the area of the surveyed to be surveyed. Okay, station should not be outside the area to be surveyed. Okay, and the last is survey lines should be taken to the fairly level ground. Okay, if there is a chances of any uneven ground, it should be avoided. So these are the points to be remembered while selecting the survey station in chain survey. That's all about the first topic, introduction of chain survey. Now we will move to our second topic of today's lecture, which is operations of chain survey. Mainly, there are three operations are there. First is chaining, second is ranging, and third is offsetting. First, we will discuss chaining. Chaining is the process of finding out the distances between 2 points. There are two types of chaining. First is chaining on the level ground. It involves various operations like first fixing your station points, then unfolding the chain. Third is ranging the chain, in which we will straight the chain. Fourth is measuring the distance using chain, and the fifth is folding the chain back. This is all about the chaining on the level ground. If the length of the chain is less than the actual distance between two stations, then arrows can be used for counting the second chain or counting the number of chains. If the chain is long enough to measure the distance between two stations, arrows are not used. Chaining on sloping ground can also be possible. It is not included in our syllabus. So we will move to the second operation of chain survey, which is ranging. So first question comes in your mind is, what is ranging? So it is the process of establishing intermediate point on the straight line between two endpoints. We will understand by one figure also. Suppose there is a survey line. Here two stations are there, station A and station B, and we require one intermediate station like this M. This is the plan of this station. We require the intermediate station exactly on the straight line between two endpoints. Finding out this intermediate point is called as ranging. Now let's discuss the various methods involved in ranging, or how we can do ranging. So methods of ranging. It is basically divided into two types: direct ranging and indirect or reciprocal ranging. So what is direct ranging? It is possible when the stations are intervisible. Indirect ranging is used when the stations are not intervisible, means you cannot see the next station from the first station. This direct ranging is carried out by two methods. First is direct ranging using necktie and ranging rods, and second is direct ranging with one instrument, which is line ranger. First we will see direct ranging with necktie and ranging rod. Suppose there is a one ground or one survey line. There is a station A, this is station B, and we have to find the station M on the straight line between two endpoints. This direct ranging is possible when the stations are intervisible and when intermediate ranging rods are fixed on a straight line by direct observation from the end station like A and B. It is called as direct ranging. Now we will see the second method of direct ranging, which is used by line ranger. It is a small instrument used for establishing intermediate points in the line with two distant signals without necessity of sighting from one of them. In first method, we have to go to the end station, station A and station B. Here, in this method, you can ranging without going to the end stations. It consists two right angle isosceles triangle prisms placed one above the other. Suppose there is a one survey line and two end stations P and Q are there. We have to stand with line ranger at the chain line like this. There is the image of line ranger. Here you can clearly see two right angle isosceles triangular prisms one above the other. If we go to the structure of this line ranger, there are two prisms. One is top prism and second is bottom prism. These both prisms are placed one above the other at right angle. We have to stand like this on the survey line and see on the top prism as well as bottom prism. We can clearly see two end stations P and Q and their ranging rods. The images of ranging rods of end station P and Q are one above the other. Then it is called as perfect ranging. Like this. The person is standing on the chain line with line ranger and see two distant signals, which is station P and station Q and their ranging rods. When the images of P and Q is exactly one above the other, it is called as perfect ranging. That's all about direct ranging when the stations are intervisible. But what can we do when the stations are not intervisible? At that time, indirect ranging or reciprocal type of ranging is used. It is usually done by one instrument called as theodolite. We will discuss whole process how we can do ranging when the stations are not indivisible. There are three conditions where indirect ranging can be used. First is when end stations are not visible due to rising ground between them. Second, when chain line crosses a valley from which ranging rod at forward station cannot be visible at the top. And the third, the distance between two end stations is too long to see each other. In these three conditions, we use indirect ranging or reciprocal type of ranging. Suppose there is a sloping ground or rising slope between two end stations. This is the first type of condition you can say. Here, if we stand at station number A, we cannot see the station number B. So direct ranging cannot be possible in this type of condition. Here, indirect ranging is used for finding out intermediate points like M and N on the straight line between two endpoints A and B. Here, you can see on the plan, we extend these lines to create the plan. This is the station A and station B. First, we have to send two persons with ranging rod at some distance from this line A and B, like this. Here, M1 and N1 is two persons standing with ranging rod. First, person standing at N1 guide the person standing at M1 to go straight on this slope so that N1, new point M2 and station A will be in one line like this. Now, next step will be person at M2 guide the person at N1 to go straight on the slope so that point M2, new point N2 and P will be in one line like this. Next, person at N2 guide person at M2 go straight on the slope so that N2, M3 and A will be in one line. This whole three processes is done by direct ranging, which we have discussed just before this topic. If we continue these processes, we can achieve 2 points M and N on the straight line between two endpoints A and B. These M and N are the intermediate points for this chain circle. So this is called as indirect ranging, and how we can perform indirect ranging on the rising slope between two endpoints. This is all about ranging. Now let's discuss the third operation, which is called as offsetting. We will discuss it by one figure. Suppose there is a chain line and there are two stations A and B are there. This is the chain line. One object is there. We have to find the distance between the object and chain line. So what is offset or what is offsetting? First we will discuss what is offset. The distance which are measured from survey line to the object is called as offset, and the method of taking offsets is called as offsetting. There are various types of offset. First is perpendicular type of offset. This is called as perpendicular offset. If the distance measured from object to the chain line is in perpendicular form or in perpendicular line, it is called as perpendicular offset. If we find the distance between object and chain line in inclined line, it is called as oblique offset, like this. So there are two types of offset based on angles. It is also classified by based on lengths. According to length, there are two types of offset. First is long offset and second is short offset. If the length of the offset is greater than or equal to 15 meter, it is called as long offset. If the length is less than 50 meter, it is called as short offset. The distance between the main station to the point of offset is called as chain edge. You can clearly see the chain edge. Okay, so in chain survey drawing, we have to find out the number of offsets and chain edge for each objects. This is usually done for sighting the objects after preparing the map. That's all about offsetting. Now we will discuss various instruments used for offsetting. There are 4 instruments can be used for offsetting. First is Optical Square, second is Indian Optical Square, third is Open Crosstalk, and fourth is Prism Square. First we will discuss Optical Square in detail. Suppose there is a chain line having 2 end stations A and B. There is an object P. We have to find out number of distances or perpendicular offset for this object. For that, we have to stand like this, okay, with one instrument called as optical square. This is a optical square. We have to stand like this, okay. This is our eye. If we show the structure of this optical square, it is like this. One square is there having 2 mirrors, I and H, at the angle of 45 degree. There are 2 side vents are there, C and E, from which we can see the number of mirrors as well as the station at P. This is called as incident ray. This incident ray is reflect from I to H and H to our eye. This C to I is called as incident ray and H to E is called as reflected ray. The main principle of optical square is the angle between incident ray and reflected ray is twice the angle between 2 mirrors. Here you can say the angle between 2 mirrors is about 45 degree and the angle between incident ray and reflected ray is about 90 degree. So if we change the angle between 2 mirrors, if we change it to 46 degree, we can achieve not 90 degree, we can achieve 92 degree. So for perpendicular type of offset, we have to set these mirrors at 45 degree angle. Here I is the actual mirror and H is about 2 parts. Above part is called as mirror and below part is the simple glass. So the reflection of the light is from P. So at the above part we can see the object P. At the below part, because of the simple glass, we can clearly see the opposite end, which is station B and its ranging rod. So at the bottom part, we can see the ranging rod at B. If the object P and station P is not in one line, so it's called as incorrect ranging. We have to move up and down on the chain line with optical square in our hand. For correct ranging, we have to fix our position so that station at P and ranging rod at B will be in one line like this. And this is called as correct offset. It is usually done by moving with instrument left or right on the chain line. The main principle, as we have discussed, the angle between incident ray and reflected ray is twice the angle between 2 mirrors. It is mainly used to measure perpendicular type of offsets. It is not used for oblique offsets. Next instrument which is used for offsetting is Indian Optical Square. This is the image of Indian Optical Square. The shape is different compared to the optical square. This is the actual structure of the Indian Optical Square. It is a brass shaped hollow box of about 5 cm size and about 3 cm depth with a handle about 8 cm long fixed underneath. The principle of working and method of operating is similar as optical square. Here M1 and M2 are 2 mirrors fixed to the inclined sides at 45 degree. AB and CD are 2 rectangular openings above the mirrors. And PQRS is the open face which is to be turned towards the object which offsets are to be taken. That's all about Indian optical square. Now let's move to the third instrument which is open crosstalk. This is different than optical square. This is the image of open crosstalk. This is the actual structure of open crosstalk. This is the simplest instrument among all. It consists 4 metal arms with vertical slits for sighting through at right angles to each other. So these metal arms are at the 90-degree angles. It is used to set out angles of either 45-degree or 90-degree. This is all about open crosstalk. Now let's move to the last instrument which is Prism Square. The name itself suggests it includes prism in it. This is the image of Prism Square. You can clearly see one prism fitted at the top of the handle. Here on structure you can clearly see one prism having 2 reflecting surfaces at 45-degree angle. The principle of working and method of operating is similar as optical square. Instead of 2 mirrors, here one prism is provided having 2 reflecting surfaces compared to optical square. It is more precise than optical square because in optical square 2 mirrors are there at an angle of 45 degree. If these mirrors are disoriented from 45 degree, we cannot achieve exactly perpendicular offset. Here in Prism Square there are no mirrors. One prism is there having 2 reflecting surfaces, so the angle is not changed and we can get accurate perpendicular offsets of the objects. This is all about Prism Square and instrument used for offsetting. That's all about the various operations of change survey. I hope you all understand these 2 topics, introduction of change survey and operations of change survey, chaining, ranging and offsetting. See you soon in the next lecture.